guys, and welcome again. Welcome back to next video from Santosgiri Chemistry Tutorials. And in this video, we'll talk about Archimedes principle and what are the concepts behind Archimedes principle and how can you understand Archimedes principle. So first, what is the statement of Archimedes principle? So let's see. So Archimedes principle: when a body is fully or partially immersed in a fluid, it experiences a upthrust which is equal to weight of fluid displaced by it. So here confusion, that is, listen one time again. When a body is fully or partially, it means that when a body, suppose this is a liquid, okay. So when a body, suppose a body is, when we immerse this body fully or partially in a fluid. So this is, suppose here fluid, that is liquid, and you know fluid means liquid or gas. So in pressure chapter we'll talk about only liquid, because according to your syllabus only liquid is given. So here fluid means liquid which can flow, that is liquid and gas. So here we'll take only liquid. So immersed in a fluid, it experiences a upthrust. So this liquid gives a upthrust, and this upthrust is equal to the weight of fluid or liquid displaced by this body, and that principle is called Archimedes principle. So now here confusion in two terms, that is upthrust and weight of fluid displaced. So what is upthrust? So upthrust, when a body is fully or partially immersed in a liquid, listen here, when a body is kept in a liquid, then it exerts upward force, and that force is called upthrust. And from, what is the formula of upthrust? You know upthrust equals to mg, and you know from derivation. So when upthrust equals to mg, so we'll derive here, don't worry. But in previous lecture we already derived, that is upthrust weight of fluid displaced, that is mg. So this upthrust given by liquid to this body is equal to the weight of fluid or liquid displaced by this body, and that is the principle of Archimedes law. So that is the idea of Archimedes principle. So let's talk about this derivation or verification of Archimedes principle. So how can we theoretically verify that weight of the displaced liquid is equal to the upthrust? So let's talk about that. So listen here. First of all, consideration part. In your derivation, first part is consideration. So let us consider. So first one is our, let us consider. Let us consider a body is immersed. Let us consider a body is immersed in here liquid. So liquid having density d. So if the density of this liquid is d, and this liquid placed in a container poses cross section area A. So if these liquids are filled in a container whose cross section area is A, so and H1, H2 and comma H be the height of height of upper surface lower surface, and finally body. So listen here. So if h1 is the height of body, upper surface of body from your liquid column. So h1 is the height, h1 that is from upper surface, and if h2 be the height from lower surface to that upper surface of liquid, so that is h2 from here to here, and h be the actual height of the body. So that is the consideration of this part. So first one, let us consider a body, that is a body immersed in a liquid, so having density, that is if the density of this liquid is d, and this liquid placed in a container having cross sectional area is a, and if h1 be the height of upper surface of body to the upper surface of body, and h2 be the depth of liquid from lower surface of body to surface of the uh, liquid, and d will be the density of the liquid, then from here, and this is the consideration part. So now confusion started here. So what can you understand, what you have to understand here? So that is, let's talk here. Okay, so okay, tell me here. Okay, so what is the property of liquid? So what is the property of liquid is that when a body is placed inside the liquid, then it exerts a pressure on that body. So listen here, when a body is placed on that liquid, then liquid gives a pressure on that body, and this pressure is in not only one direction, this pressure is in all direction. So listen here, this pressure is in all direction. So here three direction generally pressure act. So that is in upward direction. First one is at the upper surface, and which is in downward direction. At the lower surface, which is in upward direction, and one more force that is from lateral direction, one more pressure that is from lateral direction, here and here and from here. Okay, so from this figure, what you understand? Okay, from this figure, I can tell that simply. So this lateral pressure, listen here, this lateral pressure and this lateral pressure are opposite in direction. So these pressure cancel out from each other, because this lateral pressure is in this direction, then this is in opposite direction. So these are same magnitude in opposite in direction, so these cancel out. Now there are two types of pressure acting on a body. So first one is upper surface and second one is lower surface, and upper surface pressure acting on downward direction and lower surface pressure acting on upward direction. So listen here, two types of pressure, that is from upward direction, sorry, that is from upper surface, that is downward direction, and that is from lower surface, that is in upward direction. Now question from here, so tell me which one is greater, which one is greater in magnitude, either in this upper pressure or either in lower pressure? Yes, this upper pressure less in magnitude, because we know liquid pressure is directly proportional to height. So if the height is increased, depth of the liquid is, so tell me where depth of the liquid is more. In case of H2, depth of the liquid is more in H2, so the lower pressure is more, the pressure acting on lower surface is more than the pressure acting on upper surface. Okay, so what can I write here? So pressure on upper surface, so P1, that is what kind I write, what is the formula of liquid pressure? HdG. So H1 here, because from upper surface liquid height is H1, so D and G. So second pressure, that is pressure on lower surface, that is P2 equals to what? H2 dg. Okay, so here h2 is greater than h1. From this figure you can see clearly. So therefore p2 is greater than p1. So what is the net pressure exerted on that body? That is p2 minus p1. So net pressure, so P net, that is net pressure, equals to, what can I write here? P net, that is net pressure, equals to P2 minus P1, because some of the magnitude here cancel out and this one is only remaining. So P2 minus P1. Sorry, why P2 minus P1? Because P2 is greater than P1. So P2 minus P1. So what can I write? P2 equals to H2 minus H1 and dg. So from this figure, let's see here. So H2 minus H1 means height. Listen here. H2 minus H1 means height of the body. So what I write here, h, because h2 minus h1 is the height of the body, so h dg. So what is this? So pressure net acting on this body equals to h d and g. Now confusion here, that so upthrust, what is upthrust? Tell me. So upthrust is a force. Upthrust is a force. So what is the formula of force in case of pressure, in terms of pressure? Okay, tell me formula. What? Yes, yes, yes. So okay, so pressure, so what is the formula of pressure? That is P net equals to force by area. So listen here, upthrust means type of force. So here force means upthrust, because this force acting on upward direction. So that force means here upthrust. So P net into area equals to what? Upthrust, that is U, and upthrust is represented by U. So what can I write here? Therefore U equals to H dg into A, because P net equals to H dg into A, and you know A into H equals to volume, because area, sorry, volume equals to area into height. So this volume of the body equals to area into height. So what I write? V dg, and you know density equals to what? Mass by volume, and therefore mass equals to volume into density. So in case of here volume into density, what can I write here? That is mg. Okay, so it is numerically shows that from this derivation, what can I will write here? From it is numerically shows that the upthrust of a body is equal to the weight of fluid displaced. Upthrust is equal to mg, that is weight. W-E-I-G-H-T. Okay, so that is equal to weight. And so now tell me, what is the definition of upthrust? That is the second definition of upthrust. So upthrust is defined as, so upthrust is defined as the weight of the body displaced, weight of the liquid displaced by body. It's called upthrust from this definition, and from this derivation it is numerically proved that Archimedes principle, that is the upthrust is equal to weight of the fluid displaced. So upthrust equals to weight of the fluid displaced. And thank you so much.